I'm going to take a short video to talk about the art of logic. Now, scholars write books about logic, but in these tutorials we're going to focus on the basics. In the video before last we talked about doing arithmetic, and that would be, we talked about arithmetic expressions, and those are things that involve, the basic mathematical operators that you've seen since forever, things like, 5 divided by 2, or 1 or 3 plus 1. Those are arithmetic expressions, and what that really just means is that they, when we find the result of an arithmetic expression, the result is going to be some kind of number, and it might be a positive number or a negative number, it might be 0, but it's definitely at least going to be a number. And so that's one kind of expression we've talked about. We've also talked about using the assignment operator, like this. And this is also a form of an expression, and the result of this is a new variable with some value, or it might be to update an existing variable. So basically what I'm telling you here is we've got arithmetic expressions where the result is a number. We have assignment operations where the result is a new variable. And now we're going to talk about a third kind, which is a logical expression. And this should be pretty familiar to anyone who's made it past grade school in mathematics. Here's some examples of logical expressions. Now those should look pretty familiar. Of course they look familiar. So what makes them special, and why do we bother distinguishing them from arithmetic expressions? And the reason we make a distinction there is because when we use these in R, the answer is not going to be a number, but it's going to be either true or false. So true and false are actually values, just like numeric values. So let's do some samples here just to look at this. So there's one. 1 is less than 10. Looks true. And R tells us, yes, it's true. So what about the other way around? 1 is greater than 10. Well, that's false. Now, we can also evaluate variables, so we could say something like this. Okay, so we know that there's more treasure in the safe than the monthly quota. That's always good to hear. And of course we can do things a little more complicated, like 3, well, that's greater than -1. Also true. We can even put an actual arithmetic expression in and then compare it. So we could say now we'll come back to why I use a double equal sign here in just a moment. And the order doesn't matter. Oh, that one's false. They don't have to be integers. We could say, and now this SQRT2, we haven't seen that before, but what that's going to do is it's going to give us the square root of 2, which is like 1.41 something. Well, pi is bigger than 1.4, so that one's true. And I'm going to show you one last one, which is the not equals to. So if we want to say 2 plus 2 is not equals to 5, we use an exclamation mark. So that one's also true. Okay, so again, let's give us a formal definition of a logical expression. That's any expression where the result is either true or false. Just like with a arithmetic expression, we can store the output of a logical expression in a variable. And I know all this stuff seems kind of obvious, but it's going to be really important. So let's just show that we can say, if we want to remember the answer to 2 plus 2 equals not equals to 5, just to remember that that's a true statement, that 2 plus 2 is not equals to 5, we can assign it. We could say, we'll name that variable reminder. Okay, so you can see over here I have my reminder variable that just stores a value of true, whereas all the other variables are storing numbers. This one's storing a true, which which we could call a logical value or a truth value. And these are a little different than numeric values. Okay, so a few notes. First of all, for greater than or equal to and less than or equal to, well, you don't have the button for those mathematical symbols on your keyboard. So we use them like this. So if we need to test whether a number is greater than or equal to a number, we write it just like we say it. We say 5 is greater than or equal to 2, and that's going to be true. So we put the greater than and then the equal sign. And if you do it the other way around, like if you write 5 equal to or greater than 2, R is going to pitch a fit. It's going to call you some unkind things, and you don't want to do that. Second of all, the reason why we're using the double equal sign is because in R and in most other programming languages, the single equal sign is actually the assignment operator. So it's exactly equal sign, like if I say 5 equals 2, it's going to give me this cryptic error because that's exactly the same as if I was doing this. We can't assign 2 to 5. It just doesn't work. So single equals means assignment, but it's exactly the same as our arrow. We're not going to use that. So stick to the double equals when you're evaluating equality. Again, to say not equals to, we do the exclamation mark. Logical operators have a place in R's order of operations, and that is a very low priority. They're higher. They come before the assignment operator, but pretty much after everything else. So that's why it's okay for us to say things like 2 plus 2 equals 4, because R is going to evaluate this before it evaluates this. That way it's not trying to say 2 equals 4. It's going to say 2 plus 2 equals 4, and 4 is equal to 4, basically. And then the last thing I want to say is that there are a couple logical operators in R that specifically are for relating one logical value, true or false, to another. These are the main ones are and or. I'm not going to go into how they work now, but we may come back to them later. So that's just a brief introduction to logical expressions, logical operators, logical values. And this is going to be used a lot when we talk about indexing. So it's good that we covered it now.